In today's lesson, we're going to talk about scatterplots, correlation, and regression. Our key concept is that we're going to introduce the analysis of paired sample data. So you're going to have two things that are taken at the same time. The best way to represent those paired data points is on what we call a scatter plot. And then we will discuss the correlation in that scatter plot. Is there a linear correlation between our two data set, our data points between the x and the y? And then we will talk about the linear coefficient, correlation coefficient, which is called R. We are not going to do all of the computational part that comes with this. We are just going to do the interpretive and the analysis part. We are going to let technology do all the rest of that for us. Maybe. There we go. Okay. So correlation just means that you have two variables that seem to have some kind of relationship with each other. Doesn't necessarily mean that they are causing each other, but there is just a correlation between them. And it's very important that you don't, we've talked about this in a previous lesson, that you don't mess up correlation and causation. Linear correlation just means that between those two variables that we are discussing, if we plot all the points, it looks like a straight line, right? It could be a positive slope, could be a negative slope, but the pattern could be approximated to be a straight line. And the best way to look at that data is what's called a scatter plot, where you just take all the points, the x and the y, you make, and it doesn't matter what is your x and what is your y most of the time, so that won't matter. You could reverse them, it would be the same thing. And you're going to, again, these have to be quantitative, right? We have to have numbers so that we can plot them on this two-dimensional grid. And then you will just look at those points and then decide. So as usual, looking at examples is going to make a lot more sense. So we're going to start here. So if we are weighing seals with a camera, okay, we can put the seal on the scale. We can use the camera to take a picture of it, and they're talking about the overhead width of the seal versus its weight. So if you look at these points that are here, so this point looks like it's about 7.2 is the overhead width, and its weight was like, oh, I don't know, what looks like 110 maybe, 110, not even, maybe 115, probably 116 kilograms. This one looks like it's about 7.4, and it looks like it weighs about 155 kilograms. So each of these data points we could, obviously we have them in a list probably. Most times it's something that the camera automatically, well, like the scale will be set up with the camera and it'll automatically save your data to a spreadsheet or something like that. And then you can just use that spreadsheet to create this graph. But if you look, it looks like there is definitely a relationship between these two. It looks as though as the overhead width increases, the weight of the seal increases. Here's another example: heights of presidents and the heights of their opponents in that presidential race. Now notice, this is all over the place. It literally looks like somebody took paint on their hand and just splattered it on the wall and said, there you go. So I don't see any kind of correlation here. Now, just because it looks like that to me doesn't mean that it actually is. And that's where the technology is really going to help you here. Is there a relationship that we just can't see? So that's why it's really important that we actually calculate all these things and do some actual statistical analysis of them, rather than just saying this is what it looks like. So in order to do that, we are going to take all of our data, and there's this big process. And again, we are not going to do that process in our class. Just a lot of data, a lot of adding and squaring and adding stuff together. And but we are going to find what we call the linear correlation coefficient. And that is, again, denoted by the letter R. And that tells us the strength of the linear association. So if that number is close to +1 or -1, then you have so +1 means there's a very strong positive linear correlation. So you're going to have a positive slope. If it's -1, there's a very strong negative slope. So linear correlation between the data. But if that R is close to 0, it means that there's nothing. We don't have any correlation. So I would be assuming that past presidents one would be, the R value would be very close to 0, because it looks like they're just spread out all over the place. But the seal one, that we would definitely probably see an R close to 1 or +1 or -1. In our case, +1, because it was, as the seal was getting whiter, the weight was increasing. So we can go back to this data that we talked about in an earlier lesson about the shoe print length and the height of the criminals that were they did in forensic science. And as you can see at the beginning, it looks like there's a nice linear pattern, but then if you look towards the end, it kind of diverges. So this might have a linear correlation, it might not, because of this huge divergence here. And that's part of the problem, that when you only have a few data points, it's really hard to see. So like I said, we are not going to calculate this at all. I'm just going to use some statistical software, and voila, here we go. I use StatDisk, and it just spit out the information for me. So it tells you your sample size is 5, and that's kind of a big problem when you only have a few samples. We want to make sure we have many, many samples. It makes our data a lot more reliable. But if you look here under correlation results, it tells you that your R is 0.59, which it's closer to 1 than to 0, but for me, that's not a great number. And this critical R value really tells you. So what that critical R value tells you is you really, to have a positive, a really strong correlation, you want above a 0.87 or below a negative 0.87. And 0.59 is not cutting it. So because of that, we're going to say that there is not a correlation. It's not strong enough. There might be a correlation, but it's definitely not strong. It's very, very weak. And that's probably because we only have those 5 samples. We would definitely need more samples so that we can make a better judgment on that. Another thing that StatDisk will tell you is that right below the correlation results, it says p-value. P-value is the probability of getting paired data with a linear coefficient of the same R that is at least that or more extreme. So if we were just to randomly pick another point, according to this, if you look, the p-value on the chart is only 0.294. That means 29.4%. So if we choose at random another data point, there's only a 29.4% chance that it's going to have a correlation coefficient of 0.59 or higher. That's not very good. That's very, very low. And especially if you're working in forensic science, you cannot build a case on something that low. We would definitely want that to be a lot. We would want that to be much higher chance. I mean, it's pretty good, but it's not great. It's not going to be enough to build a case. So since we only have a 29.4% chance that it's going to be that or more extreme, that's not enough. We don't have enough evidence to suggest that there is that linear correlation. But again, we only have 5 samples. So what were to happen if we made more samples? That's what we really want to talk about. So just p-value, I really want you to remember that because we're going to talk about p-values later. Usually we're looking for p-values of 0.05, so 5% or lower. That is when we really can show some strength. So keep p-value in the back of your brain because that's going to come back later. So here's the same data, but now we have 40 data points instead of 5. Much, much better. Notice a lot more. That linear pattern is definitely showing up now. You can really see it. And when we ran Minitab this time, again, another statistical software package, it told us that the correlation coefficient was 0.813, much, much higher. And notice our p-value, 0. So like that's perfect. So that means this is definitely linear. We are good to go. We can build a case on this. There's a whole process called linear regression that you can find the equation of that line. And again, it's just a lot of plug and chug, and we are not going to do that in our course. We are going to focus on more interpretive. So I'm going to give you the information. You're going to interpret and analyze it. But the regression equation, when you do this process, is going to be in point slope form. B sub 0 is going to be your y-intercept. B sub 1 is going to be your slope. So point slope form, just like in Algebra 1. Sometimes they call regression lines lines of best fit. Sometimes they call them least square lines. It just depends on how old your textbook is, but they all mean the same thing. So when you run these statistical software packages, so let's go back to here's our example, right? There's the line of best fit that's been put in. How did they get this line? This is how. Here's StatDisk again. Notice down here it says regression results. So here's my y-intercept, here's my slope. Now remember, when you're talking about y-intercept, you're talking about if the shoe width was 0. Obviously, that's not going to happen, right? So you have to be careful that this equation only works within the data. We call that interpolation. Within the data, it works. Outside of the data, we call that extrapolation. Extrapolation, it doesn't work. So again, remember, you're only focusing on the data you have, not the data you might have on the outskirts. but they used that information to come up with that equation of the line, and that's the line that they put on top of the data, and notice how beautifully it fit, right? Notice back here, look at how nice that fit. So that is regression lines. So again, we're going to focus more on, here's the statistical, we put all the data in, here's what it spit out, you tell me what this all means. So it's very important that you understand what these terms mean and how you are able to explain them. There's going to be a lot of explaining going on in this section. So you can give the work a try, and then hopefully I will see you for the next lesson.